In version 9.2, we've added an enhancement for thread milling. In prior versions, when we would simulate a thread mill, we would have to define the thread mill as an end mill, or a milling cutter of some sort. This is fine to provide us with collision detection, but we did not get the measurement of the thread feature itself. With this enhancement, we can achieve this now. So what we've done is, in the tool manager, you have your standard mill, hole making, turning tool types, etc. We now have this thread mill tool type. So on this example, there are 3 different thread mill types. So we'll look at this first one, and this is a kind of your standard thread mill. As you can see, it's defined similar to a standard end mill in that you've got a shank, a cutting diameter, a flute length, an overall diameter, overall length, and an amount out of the holder. But there's also enhancements to add thread information as well, such as minor diameter, the thread pitch, either in threads per inch or unit, and the thread type, either unified, Acme, etc. These tools will create a cosmetic feature similar to a tap, providing us with thread information as well as collision detection. So in this example, we're going to create several different thread types: right-handed external thread, a left-handed external thread, a single point external thread, and then an internal thread that we create with a drill thread mill combo tool. As you can see, they create the cosmetic features similar to taps. So if I go to Excalibur and select feature history, I can select on the relevant thread and get the thread information that I need. In this case, it's a right-handed thread, major diameter, minor diameter, pitch, etc. Now I can also see the information in the logger window, and it also links back to the line of the program that generated that. With a single point thread, okay, and here's the left-handed thread so that you can see the direction of the thread. With the single point tool, you'll notice that we have the purple spiral for the thread because it was created with a single point tool. So if I select on the thread itself, then I get the thread information, and we see the same information that we had with the others. If I select on the uncut portion, you can now see that it shows that it's a cylinder in this case. So be careful where you select to get your feature history information. So let's refresh, reset, and let's play it again. And what I'm going to do here is show how we can also check for information about the thread. So this line here is the line that's going to create that right-handed thread external. It's a 0.05 pitch, so what I'm going to do is I'm going to edit this program and change that to 0.06, which will not match with the thread information of the tool. Now, when I go and I hit reset, I also want to make sure that we have our error detection turned on. So now when I hit play and I watch the tool run through, now you can see that we get the error when the pitch of the program does not match the pitch of the thread tool. So what I'm going to do now is I'm going to show the 3 different thread mill types. So the first type is your standard thread mill tool, your multi-point thread milling tool. As I mentioned before, it's similar to an end mill in that you've got the standard features of your end mill, with the exception of the thread information that's also added: your minor diameter, your pitch, lead tolerance. The next type is your drill thread milling tool. And because most of these you have to have a larger drilling diameter so that you don't mess up the cutting flutes of the thread mill, we have to give you, there's a lot more information on that. So here you have your drill diameter, major diameter, minor diameter, and then all the relevant links that go along with that, drill point angle. There's also the thread information, same as before, the thread pitch, lead tolerance, and the thread form. And then finally, we've got the single point thread tool. Now the single point thread tool, you'll notice, is a lot more simplified in that you don't have the pitch of the tool. Because this tool, because it is for a single point threading tool, you're only going to define the one point, so that now all we're going to define is the thread form. That way you can use this tool on a multiple varieties of thread pitch. Obviously, because there's no thread pitch information, there is no error checking that's going to be performed against the program itself.